Good morning, everyone. For the next 1 hour, we will be going through the topic, which is expanding the simulation horizons in this current challenging time. I'm Guru Prasad. I head the sales for EDS for the Karnataka region, and I have been in the system for last 10 years, and I'll take a couple of minutes to just brief about EDS. Then Vignesh will take over. EDS, we incorporated in 1994. It is our 25th year of operations. Unfortunately, we are not able to celebrate due to the current situation. Our focus is predominantly on the PLM solution sales, implementation, and support. We are the platinum partner for Dassault Systems, and the largest PLM and engineering solution provider in India. So we have close to more than 1,500 customers, located 11 offices in India. We are headquartered in Bangalore, very much in MG Road. We have strategic alliances with the world leaders like Dassault. Dassault is one of our key strategic partner. Also with other partners, which is revolving around Dassault platform, like quality checking tool like QChecker, a company called Technia, and also human solutions for the ergonomics simulation. We have dedicated sales and support customer satisfaction team located in centrally in Bangalore. It is directly monitored by our VP technical, and we take regular feedbacks on the support. And we have recently come up with our e-learning portal, which is having a lot of courses on the Dassault platform. So I would request you to go through that EDST e-learning page. So this is just a highlight of EDS, and I would like to introduce Vignesh. So Vignesh is our SIMULIA specialist, working with us for last 5 years. So he's been supporting our simulation users, especially helping them with the methodologies in projects, supporting them on the queries, trainings, involving in support, especially also we support a lot of IITs and NITs, so in the area of life sciences and medical devices. So he's from master. He has done his masters in MS Ramaya in Bangalore. So this is just a brief about Vignesh. So over to you, Vignesh. I think so we will be briefing about the Power Up portfolio. So this is the platform what SIMULIA offers, where we have complementing the other 3 solvers apart from Abaqus. So this webinar will be focused totally on the Abaqus users, how they can complement the other solutions like FEA, Tosca, and iSight. So over to you, Vignesh. I think you can take over.
Yeah, thank you very much for the introduction, Guru sir, and good day to everybody. It's my pleasure to present today's e-seminar on expand simulation horizons in this challenging times. So this presentation is about SIMULIA extended packaging, and what we want to do is to give a general overview of all the capabilities and how everything linked together, and what's there actually in the software. So hopefully we'll give you a good flavor for what each particular software can do, and how you can actually use them in conjunction with each other. So this is the agenda that we have here on the screen. So it's just an overview of packaging, where we'll be talking on evolution of simulation or SIMULIA brand. Then I'll be going to show you a bit more detail on Abaqus, FEA, Tosca, and iSight. So these are the 4 softwares that make up the extended packaging, and I'll take a little bit on the licensing part as well. So what's all about the power of portfolio? The question comes like this. Okay, so let's have a look back to the beginning of Abaqus and the early times of the simulation. So Abaqus has been founded in the year 1978 in Rhode Island, and later it joined Dassault Systems in the year 2005, and it has become a realistic simulation brand called SIMULIA. So since then, Abaqus technology has been heavily gone through a evolution process. Also, the SIMULIA brand has been evolved. So with the time, Dassault Systems has acquired companies like iSight, Tosca, FEA, Simpact, and so on. So as the years are coming, Dassault Systems, they are acquiring many softwares like simulation software, especially, and they're making it as a product under Simulia brand. So let me begin by introducing SIMULIA. SIMULIA is a Dassault Systems brand that focuses on realistic simulation and is very strong and is very well positioned to deliver the benefits of realistic simulation technology for the long term to the global user community, and it makes virtual testing a standard business practice that improves your product performance or reduces the physical prototypes and drives the innovation. Simulia has, it has got a different ways of licensing of products. For example, right now, like you are using a portfolio package or analysis package, which will give access to Abaqus only. In case if you want to use iSight or FEA for Tosca, then you should have extended packaging. So that is what we are talking here. So first we have Simulia Abaqus, which everyone is probably very much familiar that it's a general purpose finite element software. Then we have software called FESafe, which is actually a fatigue calculation solver. Then we have Tosca, which is a non-parametric optimizer. Then we have iSight, which will do a parametric optimization, but it will also do a process automation and many of the statistical type of things as well. Like these four softwares together will make up the extended packaging. The intent for Simulia is that to have a comprehensive suite of software that will meet all the engineering challenges for a broad range of customers. So fundamentally, like what the software is actually do, they actually like complement each other, like depending on your workflow and your products and like things like that you may want to use all of them or a couple of them, like say example, like you want to do of finite element analysis with fatigue. So we use Abaqus and FESafe. Finite element analysis and optimization. So we have here Abaqus, Tosca, and iSight. Or if you want to do the automation by using iSight, we can do the automation of your workflow, which is already established. So that can be done using Abaqus and iSight. So power of portfolio gives you the business values. So business values. So what are the business values that we are going to get using this power of portfolio? It's not about just having a set of technologies bundled in a unified licensing scheme. It's all about interoperable technologies with coordinated releases, schedules, and updates. When it comes to flexibility, like it is a one license pool wherein you have less often running and missing licenses, or more homogeneous token usage throughout the whole development process and so on. So scalability, if I talk, like it allows more tokens for technology combination. Like you can use iSight and Abaqus together, wherein more tokens are used for the customization and so on. So likewise, we have iSight and automate to standard your engineering process to easily repeat your proven processes that are already established in your organization and so on. So like this, we have four business values that we get from this power of portfolio. Again, the important point here is IT benefits. It is like IT efforts are very less to manage your CAE technologies with this licensing. So when it comes to technology value, so let's have a look into the values of this power of portfolio technologies. So here we have a realistic simulation software that is nothing but your Abaqus, where we can do all contacts, fractures, composite, co-simulations, implicit, explicit, dynamic problems. And when it comes to HPC performance, like it is like valuable, to achieve a rapid turnarounds even for large scale analysis. So we have process integration and design optimization, where it is used to automate and share engineering processes, or to integrate your multiple tools that are used in your organization, or to do a robust analysis, or for parametric design optimization, and so on. When it comes to fatigue analysis, like we have FEA, which has got methodologies like strain life based calculations, or stress life, or infinite life. You can also do a vibration fatigue, and this is the only one software which has got a extensive material library. And now we have CAD integration. So this is nothing but a associative interface between your CAD software and your CAE software, wherein you can directly bring in your CAD softwares into CAE software and you can do the analysis. Non-parametric optimization, we call Tosca as a non-parametric optimization software, where you can do a topology or a shape and sizing optimization. So we are going to see a bit detail in our further slides. So first I'll start with Abaqus. So going into some detail, like I just want to give a brief detail about Abaqus. I know already you are users of Abaqus, but just want to give you a like some background terminology on a few different products that are available within the Abaqus portfolio, like solvers and so on. So in terms of customization, when you're working in Abaqus CAE for pre-processing or post-processing, behind the scenes, it actually writing down a journal files or replay files, which uses the Python scripting language. And that's something you can use to build your own scripts with this Python scripting. So there is there is another option within Abaqus CAE to just create a macro, which is basically to copy the operations that you are doing continuously. So it's not like writing the text and using it, is something like recording the video and using the same video for the operations on another model. So we also have this drag and drop GUI builder within Abaqus CAE, where you can build the own like based on the your application. Like on the top right hand side, you can see there is vertical application. That's it's like a great deal of customization that you can do within CAE. So moving on to solver capability, we have two strong solvers within Abaqus CAE that you are already aware. That is nothing but your standard and explicit. So standard is based on the implicit solution techniques typically used in static, quasi-static types of problems, or thermal, or linear and non-linear types of analysis, and so on. So it intends to be the solver being used most of its applicable components or products across a broad range of problems, and so on. So we also have what we like refer to as a multi-physics procedure. So that's where we couple to the physics procedures, such as thermal and stress, or dynamic stress and displacement. And we can also do acoustic analysis. We have EMAG capability within standard solver. Explicit is typically used for dynamic type of things. So its main focus is actually on a high-speed transient dynamic events, such as your car crash, ballistic impact, or blast, and so on. So there are some additional features within the explicit solver which are quite useful for a limited subset of problems, such as your CEL, SPH, or DEM, which are opted in situations where excessive deformations of mesh is happening. So going into more detail, you have two different meshing techniques, that is Lagrangian and Eulerian. Lagrangian is nothing but deformation follows a mesh, whereas in Eulerian we have a static mesh and attracts the displacement and deformations through the mesh. So, and it's Applicability comes to when you're doing a problems with extreme deformation, or you can also combine, like in short, you are combining a Lagrangian Eulerian together, and you are doing analysis like you can see here, your airbag deployment, or vehicle entering into the water, or blast analysis, or tire hydroplaning, and so on. Then the other one is SPH. This is essentially is where we have particles embedded inside an element, and when the element hits like a failure criteria or time-based criteria, you break the element into these particles. So these are the good examples what we have here on the screen. So now, that was a brief overview of Abaqus. Now I'm going to talk about Tosca. So before I get into details of Tosca, there are two different methods that we can approach optimization. That is non-parametric optimization and parametric optimization. So non-parametric, what Tosca uses, and parametric is something iSight uses. So actually, there are many other things, but when it does the optimization, it uses the parametric method. So the difference between the two is, like when I talk about parametric parameters, like parametric optimization, so the parameters are things such as your like say example in your in the terms of car, like where we have thickness, or the dimensions, or the fillet areas, or radius kind of things. So it's not limited to just geometry, but you consider things like coefficient of friction or different material properties. So all these are we consider it as a parametric type of things. Whereas in Tosca, it doesn't look the problem like in that manner. It just considers the design space and then adds or remove the material based on the objectives in the criteria. So within Tosca, there is actually a Tosca fluid which is used to minimize the pressure drop, like HVAC systems or the AC inside a car, and so on. And we have Tosca structure within the Tosca. So in Tosca, we have modules like a Tosca structure, like a topology module, which is used to maximize the stiffness or minimize the weight. And we have sizing module to reduce the mass by optimizing the sheet thicknesses. And we have shape optimization, which is used to reduce the localized stresses and increase the durability. And we have bead optimization, which is generally used on a sheet metal components to increase the stiffness or eigenfrequencies of our sheet metal structures. And as I told you, like we also have a module called fluid topology optimization, which is generally used in HVAC systems to minimize the pressure drop. And Tosca is available as a plugin in other softwares, like these are the user interfaces. So in Abaqus CAE itself, there is a separate module called optimization module, wherein we can use that module for optimization. And it is also available as a plugin for both ANSYS Workbench and ANSA, where you can set up your problem and you can execute the optimization process. And here comes the workflow of Tosca structure, wherein first we created a design space of our finite element model, and we have submitted for the optimization. So based on the constraints or objective function or the design space what you have created and selected, it has removed the material, and this is the shape. So after this, we are exporting or we are doing a smoothing operation on the component to validate the file. So after smoothing operation, we have done a validation run with same boundary and loading conditions, and we have identified that there are high stresses in some locations. So based on that, we have done a shape optimization to reduce the localized stresses. If you reduce the localized stresses, then the life of the component will increase. And after that, we have exported the model into the CAD in the format of IGS, and that's the place where your CAD engineer comes into picture, and he tries to do some modifications, and he'll give you the final part. So you can see the final optimized part. So here is another example. It's a stabilizer bar link from Audi. Initially they have the design which worked perfectly, and when they changed the configuration of this component, they ended up seeing some fatigue cracks on this. So they decided that they had to reduce the stresses by 25% to actually pass the fatigue life. So essentially they had one radius in here, only one parameter. So that's uh, like they were looking to change this one parameter. So initially they ran like manually. They have done some like FEA models iterations by changing the radius to achieve the 25% reduction in stresses, but couldn't achieve. And finally they learned about Tosca, which has got a shape optimization module. So it's like a free form of geometry that uses in Tosca. So and it doesn't consider any parameter like radius. So and by using this Tosca, they actually managed to get a 30% reduction in the stresses. So, but of course, in the parametric optimization, you can see they have achieved only 18% reduction in stresses. So that's a good case study what I wanted to show you. So now moving on to FESafe. Uh, FESafe is actually a UK company which is established in the year 1990s, and later in the 2013 it got acquired by DS. So it's a technical leader in durability by design, and it's a first commercial software which has came up with a multi-axis train-based methods. So it's a first software in the world to come up with this method, and it is being used like everywhere. In you know on the screen, like you can see, it is used in not only automobile but also in heavy engineering structures or your life sciences domain, like to estimate the life of a stent or a heart valve and so on. So similarly in nuclear plant or wind turbines and aero wings and so on. So all industry verticals are using this fatigue software to know the life of the component. So first of all, let's understand the workflow in FESafe. Again, it is also a very flexible software, very easy to use or very easy to learn and so on, because the workflow looks very simple. Only thing is the data should be available with you, like the loading data or the material SN curve data and so on. So here we can see on the screen, first the CAD designer, he's giving a CAD model to your design engineer, where he's doing analysis in ANSYS, Abaqus, or Nastran, and later he's transferring the results like stresses, strains, temperature, displacement, reaction forces to FESafe, and that is the place where again we are giving a loading which is extracted from experimental testing using accelerometers or strain gauge sensors. We are capturing the load cycles and we are giving as an input in FESafe, and along with that we are also providing a SN curve data of that material, and we are running a fatigue calculation. So based on the results, you can take a call whether to sign off the test or redesign the product. So this is a simple workflow wherein quickly you can set up the problem, and very quickly you'll get the results. So many companies here in India, they use advanced finite element analysis to calculate the design stresses, but the fatigue analysis is often still done by manually picking the stress points from a spreadsheet, and doing a hand calculations or using a Excel sheet and so on. So these type of methods and hand calculations are inadequate for anything but the simplest form of fatigue scenarios, we can say. So with these methods, too much is user interpretation. So it is a user who should interpret the results what they are getting. So it is like easy to miss failure locations by focusing on the wrong section of a model, and again it's impossible to consider all conditions or alternatives and variables doing this traditional calculations. So fatigue tests are required, but when so maximum people what I like we observed is they try to introduce this fatigue calculations at the initial project status or at initial level only, but actually speaking the fatigue tests are always carried at the end of the project in order to save your time or in order to save your experimental testing setup and so on. So it is always recommended to do it at the end of your validation or the final stage for validation, so that you can save your time and money, because setting up your fatigue test is more expensive and more time consuming. So another thing to be concerned about is that cracks may not start from the the point where the maximum FEA stresses are getting into the picture. So we have a good example from Dana Automotive. They have a part it's called as a drive shaft assembly joint. When they did the analysis, the maximum principal stresses are on the exterior. So you can see on the screen, the maximum principal stresses are on the exterior side, but the shortest fatigue life is on the inside of the component. And again, that was something that was like proven out of by the physical testing as well. Here is another thing. The crack initiation depends on loading sequence. So we have another testimonial from Hyundai. It's a part of steering knuckle, and we have different load cases here. We have a low level fatigue. You can see on the screen, left bottom side, the prediction is just around the bolt area, and this is pretty close to the component failed in reality. And then they did a high level fatigue, and again, prediction is similar to where we see in reality. So, but when you combine these two load cases, you end up with fatigue crack in a different location. And again, this is what FESAF predicted, and this is what happened in the physical test as well. So, loading sequence is also a concern here when you do the fatigue calculations. And in FESAF, these are the three add-on modules available with us. One is a Verity module in FESAF, which is used to calculate the fatigue life of welded joints. And we have FESAF Turbo Life from AMEC, which is used to estimate the life of thermomechanical components like your piston, exhaust component, exhaust manifold, or turbocharger, and so on. Similarly, we have FESAF Rubber, which is used to estimate the life of elastomers, rubber components. So these are the three add-on modules to estimate the fatigue life. And these are some of the capabilities in FESAF, in standard version of FESAF. So we have strain life method, stress life method, and we have a material database. So here in FESAF, we have 500 plus material database, including your cast iron, which is already proven, or which is already authorized by Material Society. And these database consists your SN curve diagrams as well. So now moving on to iSight. So to begin with, what is iSight? iSight is essentially a toolkit that helps you to capture the repetitive task and automate them by creating what we call as a SimFlow, simulation workflow in iSight. So let me try to explain this way. We have, each one of us has our own way of working. We have many tools that help us accomplish our day-to-day task or day-to-day works and so on. So we might be using CAD tools like CATIA, SolidWorks, utility tools like Calculator, Excel, Word document, or we might be using some simulation tools like Abaqus, Answers, Rastran. So there are a couple of tools that we use at work. And so what iSight does for you is, like, it brings you the integration and execution of these tools under a common platform, and it brings you the automation so that these tools can be driven and in an automated fashion, passing data from one tool to another seamlessly without the option of any human intervention. So you can see on the right top corner, there is a typical iSight workflow that looks like it looks like a coat hanger process, like a coat hanger. You can see with a top level task optimization. So this is how the iSight simulation workflow looks like. And below you can see we have we have components. So in order to build this simulation workflow, we are using a components like a process components and application components. Application components are nothing but your Abaqus, CATIA, SolidWorks, ANSYS, ProE, UG, and so on. And we have process components like a design of experiment, Six Sigma, Taguchi, Monte Carlo, approximation, and so on. So using these components, we build our simulation workflow that you are seeing on the top right corner. iSight can also be used for a very effective data analysis, like engineering data analysis, which is extracting non-trivial information out of hundreds or thousands of data sets. So there are a number of tools in iSight that helps you to understand those correlations when you read hundreds of parameters. So as I told you earlier, iSight is a parametric optimization software, and we are considering the parameters like length, width, radius, angle, and so on. And using those parameters, we are trying to come up with an optimized design. So you'll have hundreds and thousands of data points. So we have many tools available in post-processing iSight, so that we can we have tools like a Pareto chart, or we have probability distribution graph, cumulative distribution graph, that helps you to understand better parameters that are strongly correlated or weakly correlated to each other. So we also have response surfaces that you can visualize in 3D and 2D to see how a response surface for certain parameter interactions looks like. So if you want to look at how ODB, the results file from Abaqus for a particular design look like, you can invoke a viewer from inside iSight. So all are available inside a data analysis tool. So it's a good example taken again using Abaqus component. So as I told you, you can automate your analysis, you can automate your workflows. The workflow which is already established and which is proven, that you can make it as a workflow here, and you can do a design of experiment study, and you can also do a optimization study with approximation study and so on. So it's this is how we create a simple using Abaqus component. We are creating a workflow here, and we are doing the optimization of our component. So how exactly do customers get there, or how do they include product performance or reliability? How do they reach their goals, that by using what we call the automated design strategies that are embedded into iSight? So typically what we do is what you see here is a traditional design optimization that you either done before or heard of it before, where we start with a initial design point. You can see that initial design point which is highlighted, and then we looped our design through an optimization algorithm to find an optimal design, or to meet our requirements. And you can see that optimization algorithm will find the most optimal point here. And if you notice, it is very close to what we call as a constraint boundary. So most engineering problems that we deal with here are highly constrained, and in they are bound to the some kind of constraint that we deal with. Sometimes they are constrained that I need to manufacture a product by stresses need to be within the bounds, or I need to manufacture a product by deflection cannot be more than and so and so these are the kind of constraints that we deal with. So in this process, the way optimization algorithm will work is try to find a best solution. So without really going outside the constraint boundary, then because then if it will go the boundary, then it will fall into a infeasible design space. So we cannot use those parameters for our design. So this is where it finds you the most optimal solution. So but if you look at this point, and if you start taking into account the things like manufacturability or tolerances in material property or any other kind of variability in your design process, you will notice that a lot of these parts will fail because they lie outside the constrained boundary. So now in iSight, what you can do is like you can add additional goals to your optimization that brings this design away from a critical edge, so that not only design is optimized but also like taking into account all the variabilities or randomness that exist in your design. So all the variations of designs are also optimized, so it brings you the design away from your critical edge by reducing the process variability. So this is what the exact algorithm works in iSight. So these are the benefits what you get from iSight, wherein you can reduce your design time by automating the design process. You can improve your product performance and quality by exploring the new design spaces or coming up with robust designs and so on. And you can understand your design better by doing a trade-off between your multiple objects and make your design decisions to achieve optimal design to meet the needs of the customer. So now moving on to the licensing. So the power of portfolio is offering a unified licensing. So it has got two components. One is a QAX, which is a trigram and will give access to GUIs of Abaqus CAE, iSight, FECF, and Tosca. And then second one is your QXT, which is a trigram for solver tokens. So these are meant for computational usage only. We cannot use them to open GUI for pre-processing and post-processing. Why? Because right now you are using a portfolio tokens which can be used for all three, for pre-processing, solving, and post-processing. But wherein this extended packaging, this QXT, these are solver tokens. These are used only for solving, not for opening any GUI for pre-processing and post-processing. So we have QAX, which will give you access to the GUI, wherein you can do pre and post processing. So tokens under this diagram can be used to execute your FSA for Abaqus or Tosca or iSight jobs. The same tokens can be used for all solvers. That is a beauty of this extended packaging. So how many do you need for each job? So for Abaqus and iSight, a very basic configuration of iSight, like using 5 solver tokens, you would need only one GUI as well. So for FESafe, you need 7 tokens. So one seat is minimum. For Tosca, you require 8 tokens. If you're using Tosca with Abaqus, then it requires 8. But if you're using Tosca with Answers, then you need 9 tokens. And then if you want to combine together and you you need a minimum of 13 tokens. Okay, so again, in summary, like 5 tokens for iSight and Abaqus, and so in short, I can make it like this. So minimum tokens requirement for extended packaging starts with 8, wherein it will give you access to your Abaqus, wherein you can submit your job on 4-core machine, and it will give you access to FESafe, because FESafe requires only 7 tokens, and you can also submit a Tosca linear optimization only. Like in Tosca, you can do both the linear optimization and non-linear optimization. But when you're doing linear optimization, it requires only 8 tokens. But wherein in non-linear optimization case, you require 13 tokens. So these are the minimum. When it comes to iSight, minimum token requirement starts from 1 to 10. So depending on the simulation workflow, what you're preparing in iSight, it depends the tokens consumption. Thank you. That's it from my side. Now the floor is open for question and answers. So you are